Hi everyone, we're going to start Module 6 today. And for the first section of Module 6, we want to talk about how to solve one-step inequalities. So we're going to do the same thing we did with the equations. We're going to start real simple with one step, and then in 6.2 we'll do more than one step. We'll do multi-step inequalities. But first of all, let's just talk about what an inequality is. Now if you look at the word inequality, you can see the word equal in it, but when you put the prefix in front of something, it means not. So inequality actually means not equal. It's going to be any symbol other than just an equal sign. So what we're really talking about most of all is things like less than, or greater than, or possibly less than or equal to, or greater than or equal to. So those are our four main inequalities. There are a few others that you might see, but those are the main ones. So let's go through the symbols first and make sure you know which symbol goes with which one. So this one is less than. It's the one that looks kind of like a little arrow, and it's pointing to the left. Pointing to the right is greater than. So make sure you know which one is which. If you see a less than symbol and think it means greater than, then you won't be able to answer the question. I mean, the whole thing is off. So make sure you know the difference between the two. Pointing to the left is less than. Pointing to the right is greater than. Now, either of these symbols with a little line under it means or equal to. So like the first symbol, less than, if I put the little line under it, means less than or equal to. The second symbol, greater than, if I put the little line underneath it, it means greater than or equal to. So those are our four main inequalities. Make sure you know which sign goes with which one. And let's talk about solving inequalities. Now here's the good news. Solving an inequality is exactly like solving an equation. There's just one little extra rule to remember. So here's the extra rule. If you are multiplying or dividing both sides of the inequality by a negative number. So remember, when we're solving inequalities, I said it's just like an equation. You might add 5 to both sides. You might multiply both sides by 2, divide both sides by 10. You can do anything you want as long as you do the same thing to both sides. And there's this one extra rule you have to remember. If I multiply or divide by a negative, the inequality flips, meaning a less than turns into a greater than turns into a less than, or the same thing with the or equal to. And when I do an example of one, I'll show you why. So let's do a few examples of solving the inequality. My first inequality says 3x is less than 15. And I said, okay, for now, let's just pretend like that was an equal sign. Just pretend like that was 3x equals 15. So I say, just like we did before, if I want to solve this equation, I want to isolate x. And remember, when we first started doing this, I said, you put this little dotted line down the middle, right at the equal sign, or at this time it's a less than sign, and just say I can do anything I want as long as I do the same thing on both sides of that line. My goal is to get x by itself. It's a 3x. I'm going to divide by 3. So I divide both sides by 3. 3 cancels with 3. The x stays, the less than stays. Remember, it's not an equal this time, it's a less than. 15 divided by 3 is 5. That's the answer. X is less than 5. So super easy. I mean, it was exactly the same as solving 3x equals 5. It just has a different sign in between them. All right, here's another one. We have 12 is greater than or equal to y plus 6. So I'm going to put in that dotted line again. I'm going to say my goal this time is to isolate the y. So I have to get rid of the plus 6, that's adding. So I'm going to use a minus 6 to cancel that out. Same thing on both sides of the line. Positive and negative 6 cancel, leaves just the y. I have a greater than or equal to sign. And 12 minus 6 is 6. Now here's one little tricky part. When you're solving for x or y or whatever the letter is, when it's an equation, it doesn't matter which side the x is on, or the y in this case, because 6 equals y is the same as y equals 6. Well, with an inequality, when it's written backwards, you have to read it backwards. So what this actually says in words is 6 is greater than or equal to y. Now that means y is less than or equal to 6. So if you ever solve an equation and your variable is on the right side instead of the left side, when you read it backwards, it flips the inequality. So if you get 6 is greater than or equal to y, the answer to the question is actually y is less than or equal to 6. All right, let's do one last example here. We have negative 4x is less than or equal to 56. One-step inequality, again, remember that was the title of the section. I have negative 4x. I want to solve for x. I need to cancel out the negative 4. So I would divide by negative 4. And I'm going to divide both sides by negative 4. And I say the negative 4 canceled the negative 4 and leaves the x. 56 divided by negative 4. Well, first of all, positive divided by negative is negative. 56 divided by 4 would be 14. Now, here's the thing. The common mistake is people say the answer is x is less than or equal to negative 14. But remember, we have that extra rule. The extra rule says if you are going to divide or multiply by a negative number, you have to flip the inequality. So it becomes greater than or equal to, not less than or equal to. So make sure for that question, you don't have x is less than or equal to negative 14. It has to be greater than or equal to. And I told you guys I would show you the reason for this. I will show you that right now. So let me go back to the original question. We have negative 4x is less than or equal to 56. Now, when you're multiplying by a negative, even though it doesn't show it, what happens is the two numbers actually end up flipping sides. So let me show you a different way to solve this question in 2 steps instead of 1. Actually, it'll be 3 steps instead of 1. But it'll show you why you have to flip the sign. So a different way to turn a positive number into a negative number, instead of dividing by negative 4, would be to add it to both sides, like this. So let's say I wanted to turn this 4x positive, and I said, I'm going to do it a different way. I'm going to do this by adding 4x to both sides of this equation. Because see, then the negative 1 cancels out. It actually just leaves a 0 here. And you have 56 plus 4x. Oops, 4x. And then to solve for x, remember I said this is going to be a lot more steps. This is not the easy way to do it. I'm just kind of showing you why it works. If I subtract 56 from each side to cancel that out, I have negative 56 is less than or equal to 4x. And then I divide both sides by 4. And what I get is negative 14 is less than or equal to x. Now, because the two things flip sides, now I have to read it backwards like I did in the last example. If I read this question going this way, instead of negative 14 is less than or equal to x, I get my answer from before. I get x is greater than or equal to negative 14. And that's why you have to do this. With an equal sign, it doesn't matter. X equals 14 is the same as 14 equals x. But with an inequality, it does matter. Having the x on the other side changes things. So you don't need to worry about, I don't want you to do this work over here. I showed you that once just to kind of explain why you have to change the sign when you do this. From now on, I just want you to think of it as a shortcut. I'm going to solve an equation, I'm going to solve an inequality exactly like an equation, but anytime I multiply or divide by any negative number, it flips the sign around. So it turns a less than into a greater than or a greater than into a less than. It's the only difference. All right, one other thing for today. Let's talk about a graph in inequality. You can graph, these are one variable inequality, so we have x or y only. These aren't the ones that have both an x and a y in them. One variable inequality, you can draw them on a number line, not a graph, just a number line. Just remember, greater than means to the right, less than means to the left. So let's do this for our last example today. Oh, also, we talked about this. This is the same as on a piecewise function. Whenever you have an or equal to on your graph, you want to fill in and do a dot. If you don't have the or equal to, you do an open circle. You just draw a circle and that's it. You don't fill it in. Now, for our last example, let's take our 3 examples from before and graph each one. So for each one of these, we need a number line. So for x is less than 5, I'm going to draw a number line. I'm going to put 0 right here. We'll count 1, 2, 3, 4, 5 to the right. Count a few spots to the left. If I want to show all the numbers less than 5, I'm going to start, you always start with either a circle or a dot on the number. Now this one does not have the or equal to, so I'm going to start with an open circle on 5. Just draw a circle around where 5 would be. And then you say the answer was less than's to the left. So I'm going to shade in, just kind of darken, all the numbers less than 5. And I'm going to end with an arrow pointing that way. That's what the graph of x is less than 5 looks like. Open circle on 5, darken or shade everything to the left of 5. Okay, my second one was y is less than or equal to 6. Number line again. And remember, it doesn't matter if it's x or y. Here's 0. This time 1, 2, 3, 4, 5, 6. I'm marking the key point in the problem. For this one, my answer was y is less than or equal to 6. Now this time we do have the or equal to, so I'm going to fill in the dot here on 6. But then it was less than again, so I'm going to shade everything to the left. And it actually looks a lot like our first one, except it starts at 6 instead of 5, and it has a circle, or has a dot instead of a circle. Now for the last one, the answer was y is greater than or equal to negative 14. I'll do it down here. Here's 0. Maybe I'll count by 2's this time. There's negative 2, 4, 6, 8, 10, 12, 14. We'll put negative 14 right here. We'll count by 2's in this direction too. So this one did have an or equal to. I'm going to go to negative 14. I'm going to put a dot on it. And this time it was greater than. It was x is greater than or equal to. So I'm going to shade everything to the right this time. So I kind of color in my number line to the right to show all these numbers over here that are greater than or bigger than negative 14 are part of the answer. And I put an arrow on the end. So that's it. Once you've done the work to solve, it's all about, plotting either a circle or a dot, and then shading one direction or the other to show that all of those numbers that are greater than or equal to negative 14 are answers to the problem. And that's it.